for general.
Good afternoon, my dear students. Welcome to KUTV Elimu Live. My name is teacher Kelvin Bundi Wanyabura from Kamboi Girls High School. We are going to learn mathematics today, a very interesting topic. But before we start, we always start with a word of prayer. Father, in the name of Jesus Christ, we worship you for this day. We thank you for this lesson. As we start, may you grant us the knowledge and wisdom that comes from you. In Jesus' name we pray and believe. Amen. So, as I have said, we're going to learn a very interesting topic in mathematics, and the topic is matrices and transformation. Matrices and transformation, that is our topic today. The subject is mathematics. So in Form 3, you learned about, this is a Form 4 topic, that is the first topic in Form 4. And in Form 3, you learned about matrices. And matrices is the plural of matrix. And a matrix, there is matrix multiplication, that is in Form 3. And that matrix multiplication concept is what we're going to use in this particular topic. It's a simple and very interesting topic. In Form 2, you learned about transformation. Transformation like translation. You learned about transformation like rotation. You also learned about reflection. That is transformation. So in Form 4, we're going to combine matrices and transformation. The last time I was here teaching about vectors, we talked about a translation vector plus object to give us the image. A transformation vector plus object to give us the image. So today we are going to use the same concept, but now with a matrix and not a translation vector. Still, we'll be seeing how the matrix can transform an object to give us the image. So for today, it's not the translation, but it is the matrix. So one concept that you need to understand in this topic, my dear student, is that a matrix of transformation multiplied by the object, it gives us the image. A matrix of transformation multiplied by the object, it gives us the image. So a question in the exam will come like this. Find the coordinates of the image. Find the coordinates of the image given the coordinates of the object and a matrix of transformation. So what you'll do, you'll take the matrix of transformation, multiply by the coordinates of the object to get the coordinates of the image. My dear students, sometimes they'll give you the coordinates of the image for you to get the coordinates of the object. What do? This is another important concept. If you are given the coordinates of the image and a matrix to get the coordinates of the object, we don't use the matrix. We use the matrix inverse. We use the matrix inverse. Matrix inverse multiplied by the image. Matrix inverse multiplied by the image, it will give us the coordinates of the object. Matrix inverse multiplied by the image, it will give us the coordinates of the object. My dear student, before I give the example that we are going to do, I just want us to remind you, I just want to remind you how to get the matrix inverse. So that when we start doing the example, matrix inverse was done in Form 3 matrices. So that when we start doing the example, then it is going to flow very smoothly. So let us have a small example of how we get the inverse of a matrix. You can write this. Find the matrix inverse of the matrix 2, 1, 3, 5. Find the inverse of the matrix 2, 1, 3, 5. To get the inverse of the matrix, you must first of all get the determinant. We must first of all get the determinant. And the determinant is given by, I normally tell my students, the determinant is given by the right-hand salute, that is 2 times 5. Right-hand salute, when you try to salute using your right hand, it will give you 2 times 5. 2 times 5, the right-hand salute, minus the left-hand salute, that is 1 times 3. So the determinant of our matrix will be the right-hand salute, 2 times 5, minus the left-hand salute, 1 times 3. And this will give us 2 times 5 is 10 minus 3. 10 minus 3 is 7. I know that you have your calculators. So now, we want to get the inverse of this matrix. We write 1 over the determinant, 1 over the determinant, which is 7, into bracket, interchange. Interchange the digits on your right-hand salute. Interchange the digits on your right-hand salute, that is 5 and 2. So 5 will come here and 2 will come there. Then you change the sign of your left-hand salute. Change the signs of your left-hand salute. This will be -1, -3. Then you open the bracket. 1 over 7 times 5, that will give us 5 over 7. 1 over 7 times -1, it will give us -1 over 7. 1 over 7 times -3, it will give us -3 over 7. And 1 over 7 times 2, it will give us 2 over 7. This is the inverse of the matrix. This is the inverse of our matrix. I've said this. The inverse of the matrix is given by 1 over the determinant. 1 over the determinant. You interchange the digits on your right-hand salute. That is 2 and 5. They will interchange. And you change the sign of the digits on your left-hand salute. That is 1 and 3 will be -1 and -3. Then you multiply by 1 over the determinant. And how did you get the determinant? The product of your right-hand salute, 2 times 5, minus the product of your left-hand salute, 1 times 3. My dear student, that was just a review of something that you did in Form 3 on a matrix inverse. So that when we apply it in our topic of matrices and transformation, it will be very easy for you. That was a good example. So I want us to do a 10 marks question on matrices and transformation. So that we can see how we are going to apply the formulas that we have written here. Again, sometimes you'll be given the coordinates of the object and the coordinates of the image for you to get the matrix. We'll also do a question on how we can get the matrix when given the object and the image. Quadrilateral, we have a question. Quadrilateral with vertices. Example. A quadrilateral a quadrilateral with varices, K 1 1, K 1 1, L for 1, sorry, that's not the question. Let's rewrite the question. O, A, B, C, example, O, A, B, C is a parallelogram, with vertices, or 0 0, A 2 0, B 3 2, and C 1 2, O prime, A prime, B prime, C prime is the image of OABC under transformation matrix, this is the matrix, -2 0 0 -2. And the first question A, find the coordinates of AO. Find the coordinates of O prime, A prime, B prime, C prime. That question is the first question A, and it's the question that we are going to start with. So we are told OABC is a parallelogram with vertices OABC. Full stop. O prime, A prime, B prime, C prime is the image of OABC and the transformation matrix -2 0 0 -2. Then you are told find the coordinates of the image. Let us see how we do that question. Solution. In our formulas, we say that matrix times the object is equals to the image. Matrix times the object is equals to the image. Our matrix in our question is -2 0 0 -2. That is our matrix, my dear students. The object coordinates are O, which is 0 0, you rearrange them that way, A, which is 2 0, B, which is 3 2, and C, which is 1 2. This one will give us the coordinates of the image, which is O prime, A prime, B prime, C prime. Let us begin the multiplication. First row, first column. That is how we multiply our matrix. First row, first column. -2 times 0 plus 0 times 0. -2 times 0 is 0 plus 0 times 0 is 0. That gives us our first digit there. First row, first column. We go to the next digit. Second row, first column. We want to get the coordinates of O prime. Second row, first column. 0 times 0, 0 times 0, plus negative 2 times 0, negative 2 times 0, it will give us 0. That is the coordinates of O prime. We move to A prime. First row, second column, my dear students. First row, second column. Negative 2 times 2, negative 2 times 2, plus 0 times 0, 0 times 0. It will give us negative 4. We move on to the second row. Second row, second column. 0 times 2 plus negative 2 times 0. Negative 2 times 0. It will give us 0 plus 0, which is 0. My dear student, we are still moving on well. We go to the coordinates of B prime. First row, third column. Negative 2 times 3, negative 2 times 3, plus 0 times 2. 0 times 2. That will give us negative 6 plus 0, which is negative 6. We go to the second row. Second row, third column. Second row, third column will have 0 times 3 plus negative 2 times 2. Negative 2 times 2. That is 0 plus negative 4, which is negative 4. My dear student, we move on to the image of C. Move on to the image of C. Negative 2 times 1, negative 2 times 1, the image of C, plus 0 times 2, plus 0 times 2. That will give us negative 2 times 1, which is negative 2, plus 0, that is negative 2. We move on to the second row. 0 times 1 plus negative 2 times 2. Negative 2 times 2. It will give us 0 plus negative 4, which is negative 4. Therefore, my dear students, the coordinates of the image will be O prime 0, 0, A prime negative 4, 0, B prime negative 6, negative 4, and C prime is negative 2, negative 4. Those are the coordinates of the image. We have done this. The matrix multiplied by the coordinates of the object to give us the coordinates of the image, to give us the coordinates of the image. That was question number A, Roman 1. Let us go to question, that was question number A, Roman 1. Question number Roman 2. On the grid provided, draw O, A, B, C, and O prime, A prime, B prime, and C prime. It's unfortunate that we don't have a graph board, but plotting the coordinates is very easy for you, my dear students. Let us do the calculations. You are told, Roman 2, on the grid provided, draw O, A, B, C, and O prime, A prime, B prime, C prime. You just use your Cartesian plane. Maybe I can sketch. You just use a Cartesian plane. In our Cartesian plane, we normally have the y-axis, the x-axis, 0, 1, 2, 3, 1, 2, 3, negative 1, negative 2, negative 3, negative 1, negative 2, negative 3. So my dear students, we are told to plot the object, and you have your graph book, I know that, but for me I'll just use this. So 4, 5, 6, negative 4, negative 5, negative 6, negative 4, negative 5, negative 6. So we start by plotting the object. The coordinates of the object were 0, 0, that is O. Then 2, 0, 2, 0, 2, 0, that is A. Then 3, 2, 3, 2, this is the y-axis, this is the x-axis, that is our B. Then 1, 2, 1, 2. That is our C. Remember, mine might not be very accurate because it's not a graph board, but just a good sketch. That is our object. The image is 0, 0, that is O prime. Negative 4, 0, negative 4, 0 is there, that is our A prime. Negative 6, negative 4, negative 6, negative 4 is there, that is B prime. And negative 2, negative 4. Negative 2, negative 4, it will be there. Then you use your ruler. Use your ruler to join the point. There is C prime. A prime, O prime, B prime, C prime. So what question are we answering, my dear student? The question that we are answering is on the grid provided, draw O, A, B, C, and O prime, A prime, B prime, C prime. We are drawing the object given and the image that we have calculated using our matrix of transformation. Now, my dear students, you can continue sharing your question. Questions through the number that is on your screen. I'll read the question as we conclude the lesson. We go to part B. Part B of the question. I know that you've drawn that. Part B of the question. Find, the question is B Roman 1. Find O double prime, A double prime, B double prime, C double prime, the image of O prime, A prime, B prime, C prime, and the transformation under the transformation matrix, under the transformation matrix 1, 0, 1, 0, 0, negative 2. 1, 0, 0, negative 2. Find, that is B Roman 1. B Roman 1, we are told find O double prime, A double prime, B double prime, C double prime, the image of O prime, A prime, B prime, C prime under the transformation matrix 1, 0, 0, negative 2. We are still going to use the same concept of matrix times the object is equals to the image. So our matrix solution, our matrix times the object is equals to the image. The matrix is 1, 0, 0, negative 2. The object now, I want us to read the question very well. Find O double prime, A double prime, B double prime, C double prime, the image of O prime, A prime, B prime, C prime. So the double prime is the image of the single prime. So the single prime will act as the object. We'll have the matrix multiplied by O prime, which we got as 0, 0, A prime, which we got at negative 4, 0. B prime, which we got as negative 6, negative 4. And C prime, which we got as negative 2, negative 4. This one will give us the double prime. It will give us the double prime, O double prime, A double prime, B double prime, C double prime. Again, my dear student, first row, first column. First row, first column. 1 times 0 plus 0 times 0. It will give us 0. 0 times 0. We are now on second row. 0 times 0. This is 0. 0 times 0 plus negative 2 times 0. It will give us 0. That was for the O double prime. A double prime, 1 times negative 4, first row, 1 times negative 4 plus 0 times 0, which is 0. It will give us negative 4. Second row, second column. 0 times negative 4 is 0 plus negative 2 times 0 is 0. 0 plus 0, 0. We move on now to the B double prime. First row, third column. 1 times negative 6, 1 times negative 6 is negative 6. 0 times negative 4 is 0 plus 0. It will give us negative 6. Second row, third column. 0 times negative 6 is 0. Negative 2 times negative 4 is positive 8. Negative 2 times negative 4 is positive 8. Therefore, our answer there is 8. We go to the C double prime. Again, first row. The first row gives us the digits of the first row here. The second row gives us the digits of the second row here. So we go to the first row, fourth column. 1 times negative 2 is negative 2 plus 0 times negative 4, which is 0. That gives us negative 2. Second row, fourth column. 0 times negative 2 is 0 plus negative 2 times negative 4 is 8. So our answer there is positive 8. Therefore, my dear students, the coordinates of O double prime, A double prime, B double prime, and C double prime are, you rewrite them now as coordinates. O double prime is 0, 0. A double prime is negative 4, 0. B double prime is negative 6, 8. And C double prime is negative 2, 8. That is how we get the coordinates of the second image. That is how we get the coordinates of the second image. Remember, my dear student, it is the matrix multiplied by the object. The first image here acts as the object to give us the second image. And multiplication of matrix is first row and the column. This digit times this one plus this digit times this one will give us the value of here. Then this digit times this one plus this digit times this one will give us the value there, and the procedure continues. Roman 2 of the question. On the grid provided, you can write this. On the grid provided, draw O double prime, A double prime, B double prime, and C double prime. So plotting, we hand sketched, but I know that you have your graph book where you are plotting. Now, the question Roman 2 of B requires you to plot these values, coordinates. O double prime, A double prime, B double prime, and C double prime. Plot them on the same grid that you plotted the object and the first image. Plot the second image. Then we go to question number C, which is very, very important. Question number C, which is very important. Number C is saying, find the single matrix. Find the single matrix that maps. Find the single matrix that maps. Find the single matrix that maps O double prime, A double prime, B double prime, C double prime onto O, A, B, C. So, my dear student, here you must be very keen. I'm still checking if there are any questions. So, my dear students, this part C, you must be very keen on it. Now, we are told, find a single matrix that maps the second image onto the object. Find a matrix. Find a matrix that maps the second image onto the object. So this is what I want you to understand on these terms. A matrix that maps the second image onto the object. My question is, between the second image and the object, which will come nearer to the matrix, and which one of them will be on the other side of the equal sign? Some students will tend to confuse because we said a matrix times object is equals to the image, and they'll say matrix times object is equals to the image. But this is what you use. A matrix that maps. Let me give this example. A matrix that maps K onto B. A matrix that maps K, a matrix, it maps K onto B. A matrix maps K onto B. A matrix map K onto S. A matrix map K onto A. So this is how I want us to arrange these coordinates. This is how I want us to arrange these coordinates. We have said, if you are told a matrix that maps K onto S, it means the matrix and K will be on the same side and S will be on the other side. Therefore, this is how we do it. We don't have the matrix of transformation. Let it be AB, solution. Let our matrix be ABCD. This matrix maps the coordinate of the second image That is 0, 0, negative 4, 0, negative 6, 8, and negative 2, 8 on 2. On 2. Let me erase this. On 2. The object. Our object was 0, 0, 0, 0, 2, 0, 3, 2, and 1, 2. 3, 2, and 1, 2. I hope now that is well understood and we can proceed doing the question. We don't have the matrix. My dear students, we don't have the what? We don't have the matrix. And therefore, we need to get the matrix. Remember that we used to be given the object and the matrix to get the image. But here now, we have the object and the image to get the matrix. So, my dear student, this is what we do. First row, first column. First row, first column. We cannot use O double prime and O because both coordinates are 0. It won't give us a good simultaneous equation because we are going to form simultaneous equations. We can also not use, we can use A double prime. Let us see how we do it. First row, second column gave us 2. A times negative 4, which is negative 4A, plus B times 0, which is 0, should give us 2. A times negative 4 plus B times 0 is equals to 2. Negative 4A plus 0 is equals to 2. We can get our A. Negative 4A is equals to 2. Divide both sides by negative 4. Divide by negative 4. So our A is equals to negative 1 over 2. We have gotten A. Now, let us move on to getting B. First row, second column should give us 3. A times negative 6. Let me see a better pen. A times negative 6, which is negative 6A, plus B times 8, which is 8B, should give us 3. Remember that we already have the value of A as negative 1/2. Therefore, we substitute where we have A with negative 1/2. Negative 6 times negative 1/2 plus 8B is equals to 3. What is negative 6 times negative 1/2, my dear student? This is positive 3 plus 8B is equals to 3. 3 plus 8B is equals to 3. Take 3 to the other side. 8B is equals to 3 minus 3. 8B is equals to 0. Divide by 8, divide by 8. Our B is equals to 0. We have gotten A and B. Can we get C? Can we get our C? Letter C. Now, we go to the second row. We have used the first row that has A and B, and the second column and the third columns to get A and B. Let us use the second row. Second row, second column. Let me use a different pen. Second row, second column. C times negative 4, which is negative 4C, plus D times 0. D times 0, which is 0, should give us 0. Remember, we are in the second row, so it should give us 0. So negative 4c is equal to 0. Divide by negative 4, divide by negative 4. Our c is equals to 0. Now, my dear students, we go to get the D. We go and get the D. Second row, that column. Second row, that column should give us 2. Because a second row in the third column. The second row, this is the second row in the third column, this value. We got it how? C times negative 6, which is negative 6c, plus D times 8, which is 8D, should give us 2. Should give us 2. Do we have C? I know you are responding back at home and saying, yes, teacher, we have C. And what is C? I know you have said it is 0. Yes. Negative 6 times 0 plus 8D is equals to 2. What is negative 6 times 0? I know you are saying back at home it is 0. 0 plus 8D is equals to 2. Therefore, 8D is equals to 2. Divide both sides by 8. Divide both sides by 8. And we'll get our D. Not our D, the D of the question. I know you will get the A's in your exams, not D's. So we'll get the D of the question as by 2, 1, by 2, by 2, 4, as 1 over 4. My dear students, we have our values of A, B, C, and D. Therefore, we can rewrite them as a matrix. We can rewrite them as a matrix. Let me rewrite here. And you will conclude and say that, therefore, the matrix of transformation, therefore, the matrix of transformation is, remember this, the first one was A. What is our value of A, my dear student back at home? You are saying it's negative a half. Yes, negative a half. Good. What is our B? Yeah, you are saying it's 0, 0. Very good. What is our C? Our C is 0, 0. Very good. What is our D? Our D is a quarter. Very good. Therefore, this is the matrix of the transformation. That is very good, very important. Very good, very important. Now, that is the climax of the questions on matrices and transformation. You can be asked to get the matrix. You can be asked to get the image or the object. And I've insisted here on this part C of the question because it disturbs some students. If you are told a matrix that maps, you'll be asking which and which should come first and what should come on the other side of the equal sign. It is the matrix times the very first thing you are told. Then that maps what onto what. That maps the second image onto the object. And the concept of multiplication is first row, first column. First row, first column to give us the value there. This times this plus this times this to give us that one. This times this plus this times this, the second row, to give us this one. That is the concept of multiplying matrices. Yeah, my dear students, I am going to read you a question that you're going to do on your own to test yourself. You can write it. I'm not going to write it. You can write a quadrilateral with vertices. Maybe I can write the vertices. A quadrilateral with vertices K K for Kelvin. Yeah, that is good. 1, 1. K, L for 1. M, 2, 3. And N, 1, 3. Is transformed. What is a quadrilateral? A quadrilateral is a four-sided figure. As we said in the polygons, we have quadrilateral four-sided polygon, pentagon 5, hexagon 6, heptagon 7, octagon 8, nonagon 9, and decagon. Yeah, I can hear you from home saying decagon is 10, 10-sided polygon. So a quadrilateral with vertices K, L, M, N given there is transformed by a matrix T. Is transformed by a matrix T 1, 3, 0, 1 to a quadrilateral K prime, L prime, M prime, N prime. Question A. Determine the coordinates of the image. Determine the coordinates of the image. Question B. On the grid provided, I know you are writing it. On the grid provided, draw the object and the image. Draw the object and the image. Yeah, I can see your comments here. Hello, Teacher Kelvin. I'm Joy from Moranga. Keep it up. Unafunza vizuri sana. Thank you very much. Thank you very much. Question C, Roman 1. Describe fully the transformation. Describe fully the transformation which maps K, L, M, N onto K prime, L prime, M prime, N prime. That is question C, Roman 1. Roman 2, determine the area of the image. Determine the area of the image. Question D. Find a matrix. Find a matrix that maps K prime, L prime, M prime, N prime onto K, L, M, N. Onto K, L, M, N. So, my dear students, I'm trying to check on the questions as I conclude all the comments. Yeah, thank you very much. I can see Anne from Nyandarua. The lesson is so interesting. Thank you very much. God bless you. And my dear student, as I conclude, that is all about matrices and transformation. We'll meet again on another topic. But before I conclude, Kelvin Bundi Wanyabura, am an author. I've written 3 books, but I was able to come with 1 book. The other ones I've sold all of them, but I believe I'll print more copies. My first book is Never Give Up. Never Give Up, a very interesting book that will motivate you in your life as a student and also in your life as any adult. Never Give Up. If you'd like to get a copy of Never Give Up, or my second book, which is With God All Is Well, or the third one, which is Boosting Mathematics Performance, a mathematics revision book, you can contact me through 0705 845 747. 0705 845 747. Never give up in your life. My dear student, thank you very much. Thank you very much for the lesson. My name is Teacher Kelvin Bundi Wanyabura. And before I conclude, I'd like to wish all the Form 4 candidates all the best in your KCSE. My dear Form 4s in Kaboi Girls High School, I wish you all the best. And all the students, candidates in Kenya, I'm wishing you all the best. Pray and do your best. Leave everything to God, and He is going to grant you the best grade. My name is Teacher Kelvin Bundi Wanyabura from Kaboi Girls High School. Never forget to pray before you do anything. Thank you.